This is Duke University.
I think there are a number of exciting initiatives ongoing. One of them is this Interdisciplinary Material Science and Engineering Institute. And this is the brainchild, so to speak, of a committee that was put together, headed by Stefan Zauscher. And the motivation behind this, of course, is related to the central role that materials play in our society. Energy is one very strong example. The need to provide a more recognizable home, or to collect the disparate activities going on across arts and sciences and Pratt into one more coherent location. Also to create a more coherent educational structure for our graduate students. Pull together the courses in the different schools to make it a more connected experience for them, and to provide a unified structure for benchmarking and promoting with the external community. And so with this in mind, there are 4 basic areas that we put together, or that we thought about in terms of being strengths within this institute. One is photonics and electronic materials. There's metamaterials, bio and soft materials, computational material sciences. Each of these has a center or a MRSEC associated with it that I think shows the strength that Duke has in these areas. Another important point for the Institute is to identify future target opportunities. And amongst these, and very appropriate for today, is energy materials. And this will form the 5th leg of the strengths within this interdisciplinary materials effort. And this will be co-sponsored or co-organized with the Energy Institute. So why are we interested in energy materials? I don't really need to go through this. Richard gave a very good reason why energy is important to us, but I think the important point is that the effort to try and create secure, cost-effective, environmentally benign, and universally accessible energy relies on the development of new materials and processes in order to come up with viable solutions. And why should Duke be involved with this? Well, I think one of the mottos that I've heard time and time again, I don't know if it's officially our motto, but is knowledge in the service of society. And I can't think of a better example of endeavor than to try and identify viable energy solutions. Additionally, energy materials is highly interdisciplinary, and I think that interdisciplinariness is something that Duke does very well. And we also already have ongoing efforts in many of the areas that are key to addressing future renewable energy. And we have experimental tools in place, in particular the Smith facility and various PI laboratories for addressing these issues. And finally, I think it's important that in order to be able to be effective in this field, we need to not only be inward-looking, but also outward-looking to industry, to government, to understand what the key problems are. And I think Duke is ideally situated to provide outreach to these communities to effectively address these problems. And so with this in mind, the goal is to demonstrate material solutions for cost-competitive, stable, clean, equitable energy supply, as well as provide a deep understanding of the basic underlying materials, chemistry, and physics issues. And in order to do this, I think it's important to have strength in 4 different areas: computational and theoretical material science, to build an understanding and an ability to predict new materials that have desired energy properties. Of course, we need materials discovery and development to actually develop and discover them. There's a component that involves characterization, so understanding the deep chemistry and physics going on within these materials that we can help tailor for new applications. And finally, applying these materials into devices and processes so they can have real impact on the outside world. And so by integrating both internally as well as with the outside community, I think we have a real strong program, or the possibility of a strong program, to address relevant materials technologies that will transform our energy future. And so I think this is exciting. There are a number of areas in which we're targeting progress in. One is cost-effective photovoltaics. Another is solar fuel generation. So this is generating hydrogen or carbon-based fuels from sunlight and appropriate inputs. And this involves designing effective photocatalysts, electrodes, and device architectures for doing this. Also, energy storage technologies that can help enable low-cost, long-range electric vehicles, and also a responsive smart grid that in turn can help enable renewable energy sources which are intermittent in nature, like solar or wind. Biofuels is another important area, so trying to create fuels that are cost competitive with fossil fuels, providing theoretical or computational models that can predict or describe these new energy materials for conversion and storage, and finally translating these technologies to commercial applications. So, and of course, we're looking and actively adding to this list, so if you have ideas, please let me know. And so with this in mind, today we'll have several short presentations highlighting some of the exciting activities going on at Duke. Mike is going to talk about biofuels, Volker on computational approaches, and Adrian on photovoltaics, and Isvar on energy storage. And just before getting to these, I'd like to just provide a few other brief examples. And this first one is from my group, which involves perovskite-based photovoltaics. Perovskites are a class of materials that have recently demonstrated extraordinary progress in terms of power conversion efficiency. They've gone from 3% to over 20% efficiency in a period of just a few years. And this is unprecedented in photovoltaic research. And the reason for this is because of very strong properties of these materials for photovoltaics. But there are some issues that need to be addressed before commercialization is viable, and this includes use of the heavy metal lead in the material. Also, there are some significant device stability issues that need to be addressed. And so one of the projects that we have, which is funded by the Department of Energy, is to address these issues while trying to continue to push the efficiency to higher levels. We also have a program with Jay Liu's group in chemistry where we're using his group's expertise in nanostructured materials is being used to design and engineer the interface between the perovskite and the electron or the charge carrier extraction layers to try and improve efficiency and also to create better understanding of interfacial effects in these devices. I will go through these last slides very quickly because I realize I'm running short on time. There's also interesting work going on in Jay Liu's group with Jeff Glass's group on engineering the chemistry and structure of carbon nanotubes for more effective battery materials. And likewise, some work going on in Volker Bloom's group, Stefan Zauscher and Jeff Glass group on hydrogen evolution, so designing effective catalysts for hydrogen evolution. Of course, I could have put up any number of other slides for this purpose. These are just a few examples. And with this in mind, I'd like to get to what the next steps forward are for this energy materials working group. One of the things I'm working on is putting together a set of slides that summarize the activities going on at Duke. Those slides I just put up are examples, and I'll be sending emails around requesting input on other areas. If you don't hear from me, please feel free to send me information. This information will be input into the website that Richard was describing. So this work will be tied in with the Energy Initiative and New Materials Initiative. We are coordinating energy material seminars with the Energy Initiative and relevant departments, targeting additional support, and of course looking for what capabilities we need toward making this a world-class program in this area. And so with this in mind, I'll just put up this slide advertising a new materials and sustainability class, which will be offered next fall, and I believe we may have a few minutes for questions if there are any.